In this video, we want to solve all 6 problems of AP Calculus BC. First problem of BC is exactly same as first problem of AB. So let's solve one of them. It says a customer at a gas station is pumping gasoline into a gas tank. The rate of flow of gasoline is modeled by a differentiable function f, where f of t is measured in gallons per second and t is measured in seconds since pumping began. Selected values of f of t are given in the table. Using correct units, interpret the meaning of integral of f of t from 60 to 135 in the context of the problem. Use a right-Riemann sum with the 3 subintervals 60 to 90, 90, 120, and 120, 135 to approximate the value of integral of f of t dt from 60 to 135. Because f of t is gallons per second, when you take integral, you can cancel this per second because you integral ft dt, and you can say number of gallons that you have from 60 to 135. So it says pumping gasoline into gas tank. So the rate of flow, so number of gallons flow, you can say flows into gas tank, into the gas tank from T60 to T135, and as you can see seconds, so seconds. Okay, correct unit, number of gallons, interpret, and then it says use a right Riemann sum with the 3 subintervals 60 to this part. So let's solve a new page. Okay, now we want to calculate this part 60 to 90. So if I draw the diagram from 60, the first interval 60 to 90, next one 90 to 120, and last one 120 to 135. So from 6 to 90, because we want to use right Riemann sum. So if we calculate this part, let me select. Okay, the first one, we calculate right Riemann sum f of this. 90 is what? 0. F of that is 0.15, so this level. And for 120, it will be 0.1, so this part. F of this point, we can say is this. F of this point is 0.1, and the last but 135. So it will be something like this, which is, if we calculate, 0.05. Okay, now we should calculate these areas. So the first rectangle is what? So right Riemann sum equal to, and we know integral of 60 to 135 f of t dt is approximately right Riemann sum equal to, this part is 30, this rectangle, times this part, which is 0.15, plus this part is 30 times this length, which is 0.1, plus this part is 15 times this part, which is 0.05. And in this problem, we can use calculator, and it is equal to 8.25. The unit is gallons. Okay, it was part A, this problem. Let's solve part B. Part B says, must there exist a value of C4 60 to 120 such that f prime c equal to 0. Justify your answer. Okay, so from 60 to 120. 60, 120. We know that f of 120 minus. So we want to find if we connect 60, for example, f of that is what? F of that is 0.1. If we want to consider a slope of secant line. So if we calculate f of 120 minus f of 60 over 120 minus 60, f of 120 minus f of 60 is 0.1 minus 0.1, and 120 minus 60 is 60, so it will be 0, and it will be a horizontal line between them. And if we use, okay, if we use the line between them that connect them, we will see it will be a horizontal line. And for example, for any function, we have a line that is parallel to this, and we call it MBT. F is, we don't know the exact function is similar to this. We can say f of x is differentiable, so f of x is continuous. And by using mean value theorem or MVT, we conclude what? There exists C, which C is greater, strictly greater than 60, strictly less than 120, and f prime of C equal to is parallel. We can say this tangent line is parallel to this, and it is our C. So f prime of C equal to 0. Okay? So we proved part B. Part C says the rate of flow of gasoline in gallons per second can also be modeled by G of t equal to t over 500 times cos of t over 120 squared for t from 0 to 150. And also our table is from 0 to 150. Using this model, find the average rate of flow of gasoline over the time interval 0 to 150. Okay, it's part C. And it says show the setup of your calculations. For part C, we can say it's the average rate. So when it says average rate of gasoline over the time interval from 0 to 150. So when we want to calculate average, it is continuous function, so we should calculate integral. It says from 0 to 150, integral of gt dt over this interval 150 minus 50. It is equal to average rate of flow of gasoline over this time interval. And if we use, 150 minus 0. And if we use calculator, it will be equal to 0.095997, and the unit is gallons per second squared. Okay, and here we calculated this. Part D says using the model G define in part C, find the value of G prime of 140. Interpret the meaning of your answer in the context of the problem. Okay, so G of T is this. For this part, you should use calculator and G prime of 140. Okay, so G prime is this, negative 0.00491 gallons per here, because we take derivative, it will be second squared. And sorry, for previous part, for part C, because it was average, and we should say gallons per second. Okay, so it is this. Now it says interpret the meaning of your answer in the context of the problem. G of t was what? So G of t, the rate of flow of gasoline in gallons per second. So when it is equal to negative 0. This, it says interpret. You can say exactly this definition. The rate of flow of gasoline, the rate of flow gasoline is decreasing by 0.00491 gallons per second squared at t equal to 140. Okay, so we've solved this problem completely. Okay, for improving your math, also I can say your problem solving, you can use my previous videos, for example, related to last AMC, last AME, and if you want to learn some specific things, as I said before in my previous videos, feel free to send message to my WhatsApp number in the description and comments. APBC 2023 problem number 2. It says for t from 0 to pi, particle is moving along the curve shown so that its position at time t is xt yt, where xt is not explicitly given, and y of t equal to 2 sine t. It is known that dx dt equal to e to the cos t. Time t0, the particle is at position 1, 0. So let's see how many parts are there. 4 parts. So let's solve part A. Find the acceleration vector of the particle at time t1. Show the setup for your calculations. We know that acceleration vector is, if we write it as a of t, equal to x double prime t and y double prime t. V of t equal to x prime t, y prime t. So x double prime t is what? We know x prime is what? X prime of t equal to e to the cos t. Now we should take derivative again. X double prime of t equal to e to the cos t again times by chain rule cos t prime, which is negative sine t. So it will be negative sine t times e to the cos t. It is x double prime. Y double prime is what? Y of t equal to 2 sine t from assumption of the problem. And here we can consider y prime of t equal to 2 cos t. And y double prime of t equal to negative 2 sine t. Okay? So here we can consider this part. It says, okay, we want a of 1 because at time t1, so x double prime of 1 and y double prime of 1. So first part is what? Negative sine 1 e to the cos 1 and y double prime is negative 2 sine 1. If we use calculator, it will be this, and we can say approximately it is equal to negative 1. Also, it is approximately. We can say 444 and negative 1.683. Okay, it was part A. Now let's solve part B. For part B, it says for t from 0 to pi, find the first time t at which the speed of that particle is 1.5. Show the work that leads to your answer. So speed is what? When we want to find speed is 1.5, we know that in terms of x, y, 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 it will be x prime of t squared plus y prime of t squared equal to 1.5. We know that x prime is what? From assumption of the problem is e to the cos t. So e to the cos t squared plus y prime t is what? Y prime t here is 2 cos t whole squared equal to 1.5. And if you use calculator here, you can calculate you can calculate these two values, and it says the first time. So the answer is this part. Okay, so show that. Okay, let's solve part C. Part C, find the slope of the line tangent to the path of the particle at time t1. Find the x-coordinate of the position of the particle at time t1. Show the work that leads to your answers. Okay, let's calculate first part, the slope of the line tangent to the path at the of the particle at time t. So dy dx at time t equal to 1. So we can write it dy dt over dx dt at time t equal to 1. So dy dt is this part, okay, 2 cos t. 2 cos t over dx dt. dx dt is e cos t. E to the cos t at t equal to 1. So it will be 2 cos 1 and e to the cos 1. And if you use your calculator, it will be this 0.629530. You can say is equal to 0.62 or 63. Then it says find the x-coordinate of the position of the particle at time t1. We don't have x of t, but we have what? We have dx dt. You know, dx dt is e to the cos t, and also at time t0, x is 1, y is 0. Okay, so we know x prime is this, and we know x of 0. We want x of 1. So x of 1 minus x of 0 equal to integral from 0 to 1 dx dt, or x prime dt. Now it will be 0 to 1 e to the cos t dt. X of 0 is what? Is 1. So if we take negative 1 to right side, x of 1 is 1 plus 0 to 1 e to the cos t dt. Again, here you should use calculator. Okay, and if we calculate, it will be 3.341574. It will be equal to 3.342. Okay, it was part C. Part D, it says find the total distance traveled by the particle over the time interval from 0 to pi. Show the setup for your calculations. For part D, because it says from 0 to pi, we should calculate 0 to pi and total distance traveled. So we should use this formula that it will be x prime t squared plus y prime t squared dt. And it will be equal to 0 to pi. X prime is what? X prime is e to the cos t squared plus y prime is what we've calculated. It is 2 cos t, so 2 cos t squared. 2 cos t squared dt. And if you calculate this with calculator, it will be 6.034611 and it's approximately 6.035. Okay, so we've solved this problem completely. If you want to improve your problem solving, you can use, for example, AMC problems for applying top universities. And I released in my previous videos if you want to learn the techniques for improving your problem solving in any math exam, math parts. Feel free to send message my WhatsApp number in the description comments. Problem 3 of AP/BC 2023 is same as problem 3 of AP 2023 AB. So let's solve one of them. Problem 3 says a bottle of milk is taken out of a refrigerator and placed in a pan of hot water to be warmed. And the increasing function f models the temperature of the milk at time t, where m of t is measured in degrees Celsius. T is the number of minutes since the bottle was placed in the pan. M satisfies the differential equation dm dt equal to 1 over 4 times 40 minus m. At time t0, the temperature of the milk is 5 degrees Celsius. It can be shown that m of t is less than 40 for all values of t. Yes, if you solve this differential equation in one part, we will solve it. You will see that the horizontal, we can say asymptote is 40, y equal to 40. So part A, let's solve. It says a slope field for the differential equation dm dt equal to 1/4 of 40 minus m is shown. Sketch the solution curve through the point 0.05. So you should draw it approximately. You can draw, let me draw with other color. Okay, if you pass this, it will be something like this. No, it will be, you can continue like this. And it is our vertical asymptote, okay? Or if you draw it a little better, you can draw that. It will be something like this. Okay, and you can continue. So it wants only sketch. Let's try part B. It says use the line tangent to the graph of M at T0 to approximate M of 2, the temperature of the milk at time T to equal to 2 minutes. Okay, so for solving this problem, we know that in T0, 1 point is 0.5, and we want to approximate, we know if it says in T0 to approximate line tangent. So we know dm dt for this point T0, 0.5 equal to 1 over 4 times 40 minus m. M is what? M is 5. So it will be 40 minus 5, it is equal to 40 minus 5, 35 over 4, which is 8.3 over 4, 75 to solve. And here we want to approximate m of 2, so 2 m of 2. So this line is what you can say m minus 5 equal to this slope, 35 over 4 times t minus 0. Okay. And it is what we can call this one m of t. So m of t equal to 35 over 4t plus 5. And then the problem says approximate, it is approximation with this line. So m of 2 is 35 over 4 times 2 plus 5. And if we cancel 2, 35 plus 2 times 5, 10. It will be 45 over 2 or 22.5. And if you want to determine unit, it is 22.5 degrees Celsius. Now, let's solve part C. It says write an expression for these 2m dt2 in terms of m. Use this to determine whether the approximation from part B is an underestimate or an overestimate for the actual value of m of 2. Give a reason for your answer. Here we can understand because it's concave down, it is overestimation because for example m of 2, the real value is this, the approximation is this. But let's show with t squared m dt squared. Okay, if you want to calculate, we know dm dt equal to 1/4 of 40 minus m. So dm dt equal to 1/4 of 40 minus m. Now if we consider again, take derivative with respect to t, it will be 1/4 of negative dm dt. And it will be 1/4 of negative dm dt. Again, we can use this. It will be negative 1/4 of 40 minus m. And it will be negative 1 over 16 times 40 minus m is what? Because we've approximating 0, if you consider 0 and 5, when m is 5, it will be what? D squared m dt squared, negative 1 over 16, 40 minus 5. And it will be negative 35 over 16. It is less than 0. So because it is less than 0 when you approximate, in this point is the graph concave down. And we understand, okay, it is overestimation, okay? So it's overestimation. This graph, because it is less than 0, concave down. Okay, last part, part D. Use separation of variables to find an expression for m of t, the particular solutions to the differential equation dm dt equal to 1/4 of 40 minus m, with initial condition m of 0 equal to 5. Okay, when we have something like this in AP problems, I can say 90% of the problem, we should take all things to one side, like here, separation of variables. So I say dm, I take all things related to m to left side is over 40 minus m equal to dt over 4. Then we take integral from both sides dm, or we can write it as 1 over 40 minus m dm equal to 1/4 dt. Left side will be negative ln of absolute value of 40 minus m, and the right side equal to t over 4 plus, for example, c1. Then we can say, okay, ln of 40 minus m equal to negative t over 4 minus c1, because c1 is a constant, we can say plus c2. Then we know by also graph and the assumption of the problem is our graph is always less than 40. So 40 minus m here is positive. So we can say is equal to 40 minus m equal to ln of, let me write ln of, we can get rid of absolute value. 40 minus m equal to negative t over 4 plus c2. Then we consider e to the power of these things. So it will be 40 minus m equal to e to the power of negative t over 4 plus c2. Then we consider 40 minus m equal to e to the negative t over 4 times e to the c2. Then we consider c3, we define c3 equal to e to the c2. So 40 minus m equal to c3 e to the negative t over 4. Then we can multiply by negative 1 m minus 40 equal to c4 of e. And let me tell you something. C3, we can say C3 because it's e to the C2 is positive. So let's work on this. Negative C3, e, or we can call it C. Okay, negative C e to the negative t over 4, and we know c is positive. So if you add 40, m equal to 40 minus ce negative t over 4, and we know that c is positive. So it is what we can consider, because the problem says calculate m of t. We can say it is m of t equal to this. Okay. It says the particular solution to the differential equation. This with initial case of m of 0, 50, m of 0, 5. So let's consider if m of 0 equal to 5. Then we know 40 minus ce the power of negative 0 over 4 equal to 5. Okay, so we know that 40 minus c equal e to the 0 is 1 equal to 5. So when we take c, negative c to right side, 5 to left side, 35 equal to c. And because c equal to 35, so our particular solution equal to m of t, 40 minus 35 e to the negative t over 4. Okay, so we've solved this problem completely. If you had question or wanted to improve your problem solving, you can use my previous videos in AMC many other parts. You can feel free to send message to my WhatsApp number in the description and comments for improving your problem solving and other things. APBC 2023 problem number 4 for AB. Problem number 4 is same, so we will solve one of these fourth problem. So let's solve this one. It says the function f is defined on the closed interval negative 2 to 8 and satisfies f of 2 equal to 1. The graph of f prime here, the derivative of f consists of two line segments and a semicircle here. and this semicircle and two line segments as shown in the figure. Part A. Does f have a relative minimum, a relative maximum, or neither at x equal to 6? Give a reason for your answer. Okay, let's analyze x equal to 6. F prime is 0, f prime of 6 is 0. But we should check it near 0, it will be what? Near 0, as you can see in before 6, in 6 it is 0. Before 6 f prime positive, after that positive. So it is not relative minimum, because relative minimum is like this. Before that it is negative because it is decreasing, after that positive. So for relative maximum, before that positive, after that negative. But because f prime of 6 minus and 6 plus, both of them are positive, it is the graph of f prime. So we can say neither. Okay. Part B. On what open intervals, if any, is the graph of f concave down? Give a reason for your answer. Concave down means what? Means f double prime should be negative. So f double prime means, okay, concave down means f double prime should be negative. So we can say, because we have f prime is decreasing. So here in this part it is decreasing, in this part increasing, again in this part decreasing. And because it says open interval, so you can say from -2 to 0, -2 to 0, union 4, open interval, it says. You're right, 4 to 6. Okay, our answer is this, because f prime is decreasing. Let's solve C. Part C says find the value of limit of 6f of x minus 3x all over x squared minus 5x plus 6 when x approaches 2, or show that it doesn't exist. Justify your answer. Okay, when you want to calculate a limit like this, you should replace first x with 2. So 6f of 2, and from assumption of the problem, we know f of 2 is 1. Minus 3 times 2, if we calculate, it will be 2 squared minus 5 times 2 plus 6. 6f of 2 is 1, f of 2 is 1, 6f of 2, 6, minus 3 times 2, 6, 2 squared 4 plus 6, 10, minus 10, 0, so it will be 0 over 0. So if we use Hopital's rule, we can say that by Hopital's rule, we can say limit of x approaches to 6f of x minus 3x all over x squared minus 5x plus 6 equal to limit of x approaches 2. You take derivative from both numerator and denominator. It will be 6f prime of x minus 3 over 2x minus 5. And if you replace x with 2, it will be 6f prime of 2 minus 3 over 2 times 2 minus 5. F prime of 2, because we know we have the graph of f prime of 2 is 0. So it was 0 minus 3 minus 3, 2 times 2, 4, 4 minus 5 is negative 1. So negative 3 over negative 1 is 3. Okay, let's solve part D. Last part of this problem, it says find the absolute minimum value of f on the closed interval -2 to 8. Justify your answer. Okay, here, because we want to find absolute minimum, we should check relative minimum and also endpoints. Okay, so when we have relative minimum, it is something like this: f prime 0 or undefined, and before that it's f prime is negative, after that f prime positive. So if we check here, f prime in this part is 0, before that it is decreasing, after that also decreasing. So we cannot reach any good thing. Here we will see, okay, it is 0, before that it is increasing, after that also it is increasing. So f prime positive, f prime, sorry. Let me tell you, before this part, negative, it is graph of f prime. -1, before that, f prime is positive on top of x-axis, positive, negative. So it is, because, look, when you have something like this, f prime positive, negative before that. So it is relative maximum. For this part, because before that negative, after that positive, so we should calculate x2, and okay, it's positive for 6, because before that positive, after that positive, we don't need to calculate. Also, we should calculate endpoints. So we should calculate -2 and 8. So let's calculate these 3 points. From assumption of the problem, we know that f of 2 is 1, so we need to calculate only -2 and 8. So for -2, we know f of 2 minus f of -2 is integral of 0 to -2 to 2 f prime of x dx. Okay. F of 2 is 1. We want to calculate f of -2. If we want to calculate from -2 to 2, we should calculate this area up to this part. Okay. So this part that is on top of x-axis is 2 times 1 over 2. 2 times 1 over 2, and but next one you should consider negative because it is below x-axis. So height is 2, base is 1, 2, 3. So it will be 2 times 3 over 2. You can cancel this. It will be 1 minus 3, which is -2. And if we want to calculate f of -2, f of -2, if you take it to right side, is 1. You take -2 to left side, plus 2, 3. So if I draw a table, let's consider x, f of x, -2, 2, 8. For -2, it is 3. For 2, it is 1. Now let's calculate 8. For calculating 8, I say that f of 8 minus f of 2 equal to 2 to 8, f prime of x dx. We know f of 2 is 1 from assumption of the problem. From f of 2 to 8, we should calculate this area and the red area. Red area is this part plus this part. So area of blue part is 1, 2, 1 to 2 times 2 over 2 plus area of red part. You can say, okay, let's calculate this rectangle minus this semicircle. Okay, the rectangle is what? 2 times 1, 2, 3, 4. It will be 2 times 4 minus area of this rectangle minus this semicircle. Semicircle is what? Pi times 2 squared r squared over 2 because it's a semicircle. And if you simplify this, it will be 2, 2. It will be 2 plus 2 times 4, 8. Minus, we can cancel this, 2 pi. So it will be 10 minus 2 pi. Now, f of 8 minus 1 is that. So if you add 1, it will be 11 minus 2 pi. So f of 8 is 11 minus 2 pi. Now we want to find absolute minimum. Obviously, 1 is the answer, because 11 minus 2 pi is around 3.14 and is around 6 point something. If you subtract, it will be greater than 4. Okay, so the answer here is f of 2 equal to 1. Okay, so we work on this problem. If you want to improve your problem solving, as I said before, you can use my previous videos in M.Sc BMO. And if you want to work on a specific part, as I said before, feel free to send message to my WhatsApp number in the description comments. Problem number 5. The graphs of the functions f and g are shown. The figure for x from 0 to 3. It is known that g of x equal to 12 over 3 plus x for x greater than or equal to 0, the twice differentiable function f, which is not explicitly given, satisfies f of 3 equal to 2 and integral of f of x dx 0 to 3 equal to 10. Part A. Find the area of the shaded region enclosed by the graphs of f and g. So here, if we want to calculate part A, let me show it here. We should calculate 0 to 3, the area of shaded region, equal to 0 to 3. F is on top of g, f of x minus gx dx, and we can separate it 0 to 3 f of x dx minus 0 to 3 g of x dx. 0 to 3 f of x dx equal to 10 minus 0 to 3 g of x is what? 12 over 3 plus x dx, and it will be 10 minus 12 ln of 3 plus x from 0 to 3, and it will be 12 minus 12 open bracket ln of, if you replace x with 3, ln of 6 minus ln of 3, and it will be, I'm sorry, here I should write 10. 10 minus 12 ln of 6 minus ln of 3 is ln of 2. Okay, so we've solved part A. Part B. It says evaluate the improper integral 0 to infinity g of x squared dx, or show that the integral diverges. So for part B, integral of 0 to infinity g of x squared dx, we replace g of x with 12 over 3 plus x squared dx. Then we can write it as limit of b approaches infinity 0 to b, 12 over 12 squared, we can say it's 144 over 3 plus x squared dx. Now we define that u equal to 3 plus x, then it will be limit of b approaches infinity, because b is 3 plus x integral, again b is infinity, but 0 will be 3, 144 over u squared, and because of this du equal to dx, so we can write du, and then it is equal to limit of b approaches infinity, 144 integral of u squared over u squared is u negative 2, so it will be u negative 1 over negative 1 from 3 to b. Now it will be limit of b approaches in, or we can take 144 outside limit, 144 limit of b approaches infinity. Negative 1 over u will be negative 1 over b plus 1 over 3. And it will be 144, because this part will be 0 over 3. And it will be 48. Okay, so part C. Let's see how many parts are there. Okay, 3 parts. Part C, it says let h be the function defined by h of x equal to x times f prime of x. Find the value of this integral. So if we want to calculate this integral, we should use integration by parts. 0 to 3 x f prime of x, we replace h of x with x f prime of x dx, and I define u equal to x and dv equal to f prime of x dx. So here it will be, it is u, it is dv. It will be uv minus integral of v du from 0 to 3. uv is what? U is x, v will be f of x. It should be from 0 to 3 minus integral of 0 to 3v, which is f of x du dx. X f of x from 0 to 3, it will be 3 f of 3 minus 0 f of 0, which is 0, minus this integral, and this integral equal to 10. F of 3 is what? F of 3 is 2 from assumption of the problem here. So it will be 3 times 2, 6, 6 minus 10, negative 4. Okay, so the answer of part C is this. If you want to improve your problem solving, you can use my previous videos in AMC, as I said. And feel free to send message to my WhatsApp number in the description comments. Problem number 6. The function f has derivatives of all orders for all real numbers. It is known that f of 0 is 2, f prime of 0 is 3, f double prime of x is negative f of x2, and third derivative of f equal to negative 2x times f prime of x squared. Part A, find a fourth derivative of x, and the fourth derivative of f with respect to x, and write the fourth degree Taylor polynomial for f about x0. Show the work that leads to your answer. Okay. Okay, because when we want to calculate fourth derivative of x, we take derivative from third derivative here. So it will be negative 2x f prime of x squared prime. Now we use product rule and chain rule. It will be this derivative of this part, negative 2 times f prime of x squared, and then minus 2x f double prime of x squared times derivative of this part by chain rule, x squared, which is 2x. And if you simplify, it will be negative 2 f prime of x squared, negative 2x times 2x equal to negative 4x squared, f double prime of x squared. And now it says write the fourth degree Taylor polynomial f about x equal to 0. So t4 x fourth degree, we can say it is equal to f of 0 plus f prime of 0 or 1 factorial times x, because it is about x0, so f double prime of 0 or 2 factorial x squared plus third derivative of 0 over 3 factorial x cubed plus fourth derivative of x of 0, x to the 4 over 4 factorial. Okay, so let's calculate. F of 0 is what? The problem says f of 0 is 2. F prime of 0 is what? 3. So plus 3x. F double prime of 0, it will be negative f of 0. Negative f of 0 is what? Negative 2. Okay, so negative 2 over 2 is 1. So negative 2 over 2 is negative 1. So negative x squared f third derivative in 0 is 0. So we ignore this part, and fourth derivative here. Let me calculate. If you replace 0 here, it will be negative 2 f prime of 0. This part will be 0 over 4 factorial times x to the 4. And here it will be 2 plus 3x minus x squared. F prime of 0 is 3. So 3. Negative 2 times 3, negative 6. Negative 6 over 4 factorial is negative 1 over 4. And okay, let's solve part B. It says the fourth degree Taylor polynomial for f about x0 is used to approximate f of 0.1, given that f fifth derivative of x, absolute value of that is at most 15 for x from 0 to 0.5. Use the Lagrange error bound to show that this approximation is within 1 over 10 to the 5 of the exact value of f of 0.1. Okay, so Lagrange error bound, if we want to calculate this, or E of B, we can say it is equal here to fifth derivative of, for example, SC, or we can say maximum of fifth derivative of C over what? Let's calculate. Over 5 factorial times x to the 5. And we know that C is from 0 to 0. Because it is about x0, and the point we are working on is 0.1. And here we know from 0 to 0.5 it is at most 15. So it is at most 15 over 5 factorial times 0.1 to the power of 5. So it will be what? X here is what we want to approximate f of 0.1. So 15 over 5 factorial times 1 over 10 to the 5. If you divide 5 factorial is 1 to 5, product of them. 3 and 5 will be cancelled, so it will be 2 times 4. So it will be 1 over 8 times 1 over 10 to the 5. And here, and it is less than, the problem says prove that is, you can obviously see that is less than 1 over 10 to the 5 because 1 over 8 is less than 1. Let's solve part C. Okay, part C, it says let g be the function such that g of 0 is 4 and g prime of x equal to e to the x f of x. Write the second degree Taylor polynomial for g about x0. So t2 of x equal to g of 0 plus g prime of 0 times x plus g double prime of 0 over 2 factorial x squared. So g of 0 is 4. G prime of 0 is what? G prime of 0 is e to the 0 f of 0. E to the 0 is 1, and we should work on f of 0. F of 0 is what? F of 0 is 2. So it will be what? It will be 2. So plus 2x g double prime. Because g prime of x equal to ex fx, f of x, then we use product rule. It will be e to the x f of x plus e to the x f prime of x. And we want to find g double prime of 0. It will be e to the 0 f of 0 plus e to the 0 f prime of 0. E to the 0 is 1, so it will be f of 0 plus f prime of 0. F of 0 is 2, f prime of 0. From assumption of the problem, it is 3. So it will be 2 plus 3 equal to 5. So we can replace 5. It will be 5 over 2 x squared. Okay, so we solve this problem completely. And as I said before, if you want to improve your problem solving, you can use my previous videos. I solved many last exams, like last AMC, last AME, last USAMO, last PMO. And also, if you want to work on a specific part, feel free to send message to my WhatsApp number in the